Hey guys, this is Mrs. Harbin, and this is Advanced Math Presentation 1.2. Today we're going to talk about simplifying algebraic expressions. Our biblical integration for this lesson is this. We know that the stability of anything is dependent upon its foundation, and you as the student are building on more difficult concepts on the foundation that you've already hopefully laid in mathematics. Just as a solid foundation is necessary in math, so a trusted foundation is also necessary in life. Jesus is the foundation on which we should build our lives, and that is a really good metaphor for this foundation that we're building in math. Our lesson objective is this. By the end of this lesson, you, the student, will classify polynomials by the number of terms and degree, add and subtract polynomials, and apply definitions and properties to simplify expressions. Let's take a quick look at our property of exponents. Now, this should not be new information to you, so I'm not going to go over this in detail. You've got a handout in the resources section of your binder that you can always refer back to as well. But knowing these properties of exponents helps us to simplify terms and algebraic expressions. So make sure that you're familiar with this and know where to find this handout in case you need it during class. When we talk about polynomials, a term is generally considered to be simplified when each base appears only once. All fractions have been reduced, and there are no parentheses or negative exponents. So those are the three things that if we can say, okay, we've done these three things, then we have simplified it as much as possible. There's only one of each base, all fractions have been reduced, and there are no parentheses or negative exponents. Let's take a look at an example and simplify. 4x squared y times negative 3x to the negative 2, y to the negative 4th. Now we know this is not simplified for a number of reasons, but first I see some negative exponents and I also see some parentheses. So to simplify this, we can take 4 times negative 3x squared plus negative 2 squared. We've got these two bases and exponents that are the same that we can combine using the rules of exponents. And then we've got this y to the first power and y to the negative 4th power. And we can combine those terms again using those rules of exponents that I mentioned at the beginning of this lesson. When we've done that, we've got negative 12 x to the 0 power and y to the negative 3. We're still not simplified yet. We don't want any negative exponents. And the way that we can get rid of a negative exponent is by putting it in the denominator of a rational number. X to the 0 power is just 1. Anything to the 0 power is 1. So at the top, we're left with negative 12 over y to the 3rd power. See if you can simplify this expression using the rules of exponents. Pause if you need to, try to solve it on your own, and then check your work. We can combine our r terms since they have the same base, our s terms since they have the same base, and our t terms because they also have the same base, and we're multiplying and dividing. Our r term simplifies to r to the 5th, s to the negative 2, and t to the 2nd power, but we can't leave that negative 2 in there, so how do we get rid of a negative exponent? Move it to the bottom of a denominator. We end up with r to the 5th t squared over s squared. There are no more fractions that can be reduced, no negative exponents, and no parentheses, so we have simplified this expression. Here's another one. Pause the video, try this on your own, and see if you can simplify this one. First, we're going to apply that square term on the outside of the brackets to the two things inside of the brackets. So we get negative 2ac 4th, all of that squared, all over 5b to the 3rd, and all of that is squared. Once we've done that, we can use those rules of exponents to kind of simplify that again. Negative 2 squared, a squared, and c to the 4th squared. At the bottom, we've got 5 squared and b 3rd squared. We're going to continue to use those rules of exponents to get 4a squared c to the 8th, all over 25b to the 6th. We have no more bases that are similar, no more parentheses, and no negative exponents. Pause the video, try this one on your own, and see if you can simplify. We're going to distribute that third power to everything in the inside here. And do the same thing with this -2 power over here, distributing that to everything inside that set of parentheses to get this next step right here. When we simplify that, we have 3 to the third is 27, and 2 to the -2 is 4. We're going to put that at the bottom of the denominator since that was a negative exponent. And then we've got our x terms that we're combining and our y terms that we're combining. Not quite simplified just yet. We do have to stop here because we can't really subtract 6n minus 6 because of that variable, nor can we add 6 plus 4m because they are not like terms. This one has a variable. That is as simple as it gets. Let's go over some vocabulary you need to know. A monomial, mono meaning one, is a single term expression containing a constant, that's just a number, a variable with a whole number exponent, or the product of a constant and one or more such variables, and that's called a monomial. The numerical factor is called the coefficient. So in 4a, our coefficient is 4 and our variable is a. A polynomial is an algebraic expression of one or more monomials. So we have all these monomials, put them together, and we have a polynomial. A binomial is a polynomial with exactly two terms. You should be familiar with the root bi, which means two, like in bicycle with two wheels. So 4a plus 5b is a great example of a polynomial. A trinomial is a polynomial with exactly three terms. Tri meaning three, like in triangle or tricycle. 4a plus 5b plus 7c squared is a good example of a trinomial. Each of these being one term. The degree of a monomial is the sum of the exponents of its variables. So in 4a, a has an exponent of 1. It's implied, we don't write it, so the degree of that monomial is 1. The degree of a polynomial is equal to the degree of its highest degree term. So if we look at all these terms, 4a has a degree of 1, 5b has a degree of 1, 7c squared has a degree of 2. Since the degree of the highest degree monomial is 2, the degree of the whole polynomial is also 2. Like terms are terms that contain the same variables with the same exponents. We can add and subtract like terms as long as they have the same variable and the same exponent. When we're multiplying terms, they don't have to have the same exponent, but when we add and subtract, they must be the same. So let's simplify this expression here. We have no multiplication or division, only addition and subtraction. We see x squared, x squared. We have a like variable with like exponents. We can combine those. X and x, like variable with like exponents. We can combine those. And then we've got two constants down here with no variables that we can also combine. We're going to regroup that so our x squared terms are together, our x terms together, and our constants are together. And when simplified, we have 8x squared minus x plus 1. We cannot combine these with addition or subtraction because they do not have the same exponent. Please be aware of that. Try simplifying this expression. Pause the video, work it out on your own, and then come back here to check your work. The first thing that we need to do is distribute this 2a and multiply it by everything inside the parentheses. And we get this second line right here. Once we've done that, we can just combine through addition and subtraction. Now be very careful. We have an a third b right here. And we also have an a third b right there. So we can combine those two. We have an a squared b, but no other a squared b. So nothing to combine with that one. Here we have an AB to the third term, and here we have an AB to the third term. So we can combine those two. And lastly, we have an AB squared term, and nothing else that we can combine with that AB squared term. Remember, we're looking at the variables and the exponents to see what we combine. They must have the same variable with the same exponents in order to combine them through addition and subtraction. When we combine all of those terms, we end up with negative a cubed b plus 2a squared b minus 3ab squared minus 4ab cubed. All right, guys, today we classified polynomials by their number of terms, monomial, binomial, trinomial. All of those are examples of polynomials. And their degree. Remember, that was looking at the highest degree of the term inside the polynomial. The term with the highest degree determines the degree of the polynomial. We also added and subtracted polynomials, remembering that we can only add and subtract like terms, terms that have the same variable raised to the same exponent. We cannot add x squared plus x because they do not have the same exponent. We also applied definitions and properties to simplify expressions. If you guys have any questions, be sure to ask me next class.